Now let's work on example 7. In this example, we're going to examine what's the benefit about having flexible resource. In other words, if we talk about workplace, what is the benefit if we hire somebody who is flexible or hire somebody who is multi-skilled? So we're going to simulate a repair shop. For this particular repair shop, they provide two kinds of service, type A and type B. So to provide two types of service, there are two different options you can do. You can either hire two people, one specialized in type A service, other one specialized in type B service. They work independently. Or the second scenario, you can hire two dual specialists. So these people are flexible. They can do both jobs, A or B. It doesn't matter. In scenario 1, we have two specialists who can only handle one type of job. So we want to compare these two different scenarios to see which one's better, or which one's better, how much better. So create a new file, save it as example 7. Add the following modules we have create. Because we have two kinds of service, so we need a decide module. So for decide module, the first one we do is that type A service. So we have process module. Then we have dispose. Then click decide module. We're going to add another process module. This is type B. We need to dispose as well. So that is a model. So for create module, double click. This is a customers arrive. Entity type is customer. For this example, the arrival process is exponential distribution with average in arrival time is 1 hour. So we don't have to change anything. It's 1 hour default, 1 hour exponential. Then we click decide module. Type A or B. This is a simple case. So we assume 50% customer look for type A service and 50% customer look for type B service. That's 50%, two-way by chance. Click OK. Before we handle the two process module, let's define the resource. So how do you define resource? We can click a resource. So right now, I don't have any resource. It's empty. So double click. To add a new resource, we can double click. And then the first resource we give a name. It's called type A specialist. This is the one. We can drag it so we can show the full name. Type A specialist. I have one type A specialist. Double click it. You can add another one, type B specialist. I have one as well. So one type A specialist, one type B specialist. I want to add another one. This is dual specialist. How many I have? 2. So I define 3 kinds of resource. Type A, I have one type A, one type B, 2 duals. So eventually I want to create 2 different scenarios. In scenario 1, I hire 1A, 1B. In scenario 2, I hire 2 dual specialists to see which one's better. So I have 3 kinds of specialists. Now let's go to the process module. So double click process 1 module. Give a name, it's called type A service. Object action, cease delay release. Resource we have to add. So what's the resource? So right now, you don't have to type. Okay, you don't have to type. It's a resource. We don't have to type the name because we already defined. So what resource? For type A service. So first of all, let's handle scenario 1. So for scenario 1, type A service is handled by type A specialist. So we just use a drop-down list to choose a type A specialist. You don't have to type. We're already defined. Click OK. And the distribution, if you read the question says for type A service, the service time follows triangular distribution. Minimum 0.5, most likely 1.5, and maximum 2 hours. So it's hours. Click OK. For type B service, double-click Process 2 module. Type B service. Logic action easily release. Resource. Go to resource again. We don't have to define type B specialist. It's already defined. So we just go to resource name. Use a drop-down list to pick type B specialist. Click OK. Service time distribution, against triangular distribution, minimum 0.5, most likely 1, maximum 1.5 hours, default. Click OK. Then for the 2 disposed modules, we need to change the name. This one is called type A, customer sleeve. Second one, type B, customer sleeve. So this is the model. Go to run setup. We're going to run this for 160 hours, 1 month. So for under project parameter, give a name. It's called repair shop. Repair shop analysis. And your name. This is for informational. You don't have to have it. This is only for informational. Go to replication parameters. We're going to run for 160 hours, 8 hours each day. So base time units, we're going to use minutes. So 8 hours per day, 160 hours. We run for 20 days. That's it. Save it and run. We can run faster. So look at the results. Well, let's look at what's the average wait time. The average wait time is 30.34 minutes, so it's about half an hour. But currently, for scenario 1, if we hire 1 type A specialist plus 1 type B specialist, the average wait time is about half an hour, 30 minutes. So this is scenario 1. Close the report. End the simulation. So end the simulation. Save it. Now let's look at scenario 2. For scenario 2, everything else is the same. The only difference is that we're going to hire. We no longer need a type A specialist and type B specialist. Instead, we're going to hire 2 dual specialists. So everything else will stay the same. Distribution, arrival process, everything will be the same. So go to the process module for type A service. Right now, we hired 1 type A specialist to deal with type A service. So we click edit. Click edit. So on the resource name, we no longer need a type A specialist. Instead, we're going to use a dual specialist. So change to dual specialist. Click OK. Click OK. So that's for type A service. For type B service, the same. Double click on the resource, click edit. So right now we use type B specialist to handle type B service. So we change it to dual specialist. Click OK. And let's see what will happen. So that's all we have to do. Change to process module. Save it. Now you can run simulation. So remember, in scenario 1, if we hire 1 type A specialist plus 1 type B specialist, the average wait time is about 30 minutes. Now we use dual specialist. We can see average wait time is much shorter. It's about 12 minutes. It's a little over 12 minutes compared to 30 minutes in scenario 1. So having flexible resource or having somebody who can do multiple different kinds of jobs can help the service system. It's much better. So this example shows the benefit of having flexible resource or somebody who's multi-skilled. So let's close the report, end the simulation, save it, and close it. Now let's work on example 8. Example 8 is basically the same as example 5. So we start from example 5. We only add some new feature, animation feature. So let's open example 5. Example 5. Open it. We're gonna remember. Example 5 is about DMV. So we will start from here, adding some features. We don't change the simulation model. We just add some new feature. So open example 5 and save as example 8. We don't want to lose example 5. Save as example 8. So we want to add some animation feature. So what we really want to know is this: for DMV office, it opens from 8 to 5. We want to see we want to see the dynamics of the people waiting in the queue. How many people are waiting at different time periods? So with the current simulation model, we don't have this information. So we want to have more detailed information about how many people are waiting at different time periods. So we want to plot a graph. So how do you plot the graph? If you go to the toolbar, you can see plot. So click it. So you can plot many different things. So here, the only thing we want to plot is the number of customers waiting for driver license service. Because there are different queues. Here, in this example, there are two different queues. One is a queue for driver license service. The other one is the queue for vehicle registration service. So in this example, we only want to show the queue length for driver license service. So we add a data series. Click add. I have data series. Give a name. Name is a number of customers waiting for DL service. And we have to build expression. So expression, we have to tell Arena which variable you want to display. So this is the name. Under expression, choose build expression. So basically, we want to tell Arena we want to show the queue length for the number of people waiting for driver license service. So click build expression, queue length. So we click queue. Which one we want to show? We want to show the current number in queue. We click current number in queue. So there are two different queues. You can see if you click a drop-down list, you can see there are two different queues. Make sure you choose the first one, driver license service queue. You can also plot the other one if you want to try later. So right now we want to do the driver license service queue. The current number in queue, driver license, that's it. And that's it. This is expression. So you don't really have to type. You can just click and choose. And click OK. So this is the variable we want to demonstrate. Then go a little down for the line. The draw mode, I don't want to do point to point. This is formatting issues. It's not critical. So I want to do stairs, like stairs. Then I wanted to go to axis, x-axis or y-axis to change some formatting issues. Again, this is not critical. The only thing that is critical is this one, expression is critical. Other things are formatting issues. For axis, so choose x, time axis, x-axis. So scroll a little down. Because simulation, remember, we're running simulation from 8 a.m. to 5 p.m., so 9 hours. So everything is interpreted as minutes. So the minimum is actually 0, maximum is actually 60 minutes times 9 hours, 540. So how do we get 540? 60 minutes per hour. We're running simulation for 9 hours, so that's why it's at 540 minutes. So major incremental will use 60 minutes. 60 minutes, 1 hour. So this is formatting issue. We also need to do this for the y-axis. So choose y-axis. Y-axis shows the number of people waiting. So maximum, I did a simulation before. It looks like for this particular one, it will never go above 30 people. So I can choose 30. No more than 30. Maximum. Major increment, I choose 5. Again, this is formatting issue. 30 and 5. And go a little down. For 2 auto scale, I don't want auto scale. I choose false. I don't like auto scale. Auto scale is too flexible. I want everything fixed. So I don't want auto scale. So false, false. And I click OK. So once you click OK, you can see the mouse. Now it's different, right? So what you need to do is you need to pick the location where you want to plot the graph. So click once. First time you click it, specify the upper left corner for your graph. And then the second time you click it, specify the lower left corner of the graph. So this is a graph. This is a graph. Then you can run simulation, and you can see how the number of people waiting in line for driver license service will change over time. I want to make sure the animation speed is slow, so I can see all the details. Make it a little slow, sliding the door to the left. So now let's run simulation. Pay attention to this graph. Now you can see the people. This one shows how many people are waiting. So far, no more than 5. So this is animation plotting. Very good for presentation purpose. If you want to show this to your clients, it's very good. Very fancy feature. Let's make it a little faster. So far, it's good. First hour, second hour, not a big problem. The third hour, the fourth hour is not big problem. Now, later in the afternoon, you can see it becomes larger and larger. More and more people waiting. In the morning, it's fine. In the afternoon, it looks like it's very busy. So only if you plot this, you can see the dynamics. So that's something we want to learn. Okay. Of course, you can see the report you want to see. Well, we already see the report because we didn't change the simulation model. We basically added some animation feature. So that is example 8.